Hi, and welcome to DLC's video tutorials. Today we will be going over slope as a rate of change, and slope using the formula. So first, let's define slope. So to find the slope of a line, it's defined as the rate of vertical change to the horizontal change. Another way you could put it is it's the difference in the y coordinates divided by the difference in the x coordinates. Sometimes you'll also hear the rise over the run. So for notes, we could say it's the difference, and in mathematics we use delta as the difference, so the difference in the y's divided by the difference in the x. You'll also see y2 minus y1, which is the difference in the y's divided by the difference in the x's, which is x2 minus x1. And then of course you'll also see the rise over the run. So before we start finding slopes of lines, let's just go over some basics. If your line, and the way we read, just like the way we read in English, we read from left to right, so I would say read the graph from left to right. Just as I'm reading from left to right, you read the lines from left to right. And because from left to right this is going up, we say this is a positive slope. Here, because from left to right it's going down, we say it's a negative slope. Remember, we go from left to right. Here it doesn't matter. If it's a horizontal line, we say it's zero slope. Remember, horizontal line, zero slope. If it's a vertical line, we say it's no slope. Sometimes you might see does not exist, sometimes you might see undefined. But just remember, it's no slope, undefined, does not exist. There's just no slope. Okay, so now let's go ahead and do some examples. So here what we're going to do is we're going to find the slope between each given point. So let's do the first one. So we're going to find the slope from C to D. And what I'm going to do is I'm going to make it easier. I'm going to draw lines to help us out. So let me just do a shape here. Okay, from C to D. So from C to D, just going to connect them just to help us out so we won't get confused. I don't know if that helps. Okay, let me get my pen back. Okay, so from C to D, it's right here. Now, from left to right, we know it's going down, so we know it's negative. Now, what we do is we start from the left point, and to get to from C to D, from here, first we go vertical. Did we go up to get to D, or did we go down to get to D? Well, it looks like we're going down. Now, down would be negative. So negative 1, 2, 3. Okay, now we're on the same level. So we went down 3. Okay, so that's the change in the y over. Then we went right, and right would be positive. So right, 1, 2, 3. So 3 to the right. Right here we can simplify it. Just using mathematics, you know that a negative 3 divided by a positive 3 is equal to negative 1. So because this is negative 1, you could also say, well, negative 1 is the same as negative 1 over 1. Let's see if that's true. Negative 1, 1 to the right. Negative 1, 1 to the right, or positive 1. Down 1, 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. So it looks like that is our slope. Our slope is negative 1. Okay, let's do the next one, B and C. I'll go ahead and draw a line just to help us out. B to C. Looks like I missed the first point, but that's okay. I can move it. Right. Okay, that's much better. Let me get my pen back. Okay, so from B to C. So from B to C, I start at point B, and I do the vertical change first. So do I go up or do I go down? Well, if I go down, I'm getting further away from C. So I go up. Up how many? 1, 2, 3. Now I'm on the same level. So we know it's 3. Okay. So now that you're on the same level, did you go right or left to get to C? Well, we went right, so that's also positive. How many? 1, 2, 3, 4, 5, 6. So up 3, 6 to the right. And simplify this. 3 over 6, when you reduce, we divide both the top and bottom by 3, and we get 1/2. Now let's see if that's true. 1/2 means that, remember, the top is the vertical change, or the change in the y. The bottom is the horizontal change, or the change in the x's. You could also say the rise over the run. Rise means you go up and then you fall. You go down. Run, you go run left or right. Right? You can't run up, you can run down. So this is 1 over 2. Up 1, 2 to the right. Let's see if that's true. Up 1, 2 to the right. That's right. We're on the line. Up 1, 2 to the right. There you go. Up 1, 2 to the right. So our slope of line BC is 1 over 2. Let's do EF. EF, that's easy. It's a vertical line. We don't have to draw a line to figure that out. We know that if it's a vertical line, we could say no slope. Or you could say undefined. Or does not exist. What about A and E? Looks like that is a line, so I'm going to go ahead and draw that just to help us out. Okay, looks like I missed it again, but good thing right here I could fix it. Okay, right there. Let me just move this a little bit right there. Okay, let me get my pen back. Alright, so A to E, we know from left to right it's going up a little bit, but nonetheless it's still positive. It's still going up. So from A to E, from A to get to E, remember it's the rise over the run. Did we go up or did we go down to get to E? It looks like we went up 1. Now that we're on the same level, how many did we go to the right? Okay, so up 1, that's 1 positive, and then to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So up 1 and 12 to the right. That is already simplified, so you don't have to simplify that. You don't have to reduce 1 over 2. It's already in simplified terms. Now B and D. B and D is a horizontal line. Once you see a horizontal line, you say it's 0 slope. 0 slope. Or you could also say 0, because that's your slope is 0. Okay, B and F. B and F. Okay, that's the lines. Let's go ahead and draw that. This is our last one. And then we are on to the next lesson. Okay. So there's our line. So we know that from left to right it's going down, so we know our slope is going to be negative. So from left to right, let's do our vertical change first. Did we go up? No. We're going further away from F. We went down. How many? 1, 2, 3, 4, 5, 6. We went down 6. Down is negative. And then once we went down 6, we went right how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's do that again just to make sure. We went down 6, 1, 2, 3, 4, 5, 6, and then to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's right. Down 6, 11 to the right. So our slope is negative 6 over 11. Okay, so this is finding the slope by looking at 2 points on the line. Okay, you do the vertical change divided by the horizontal change, the rise over the run. Now what we're going to do is we're going to find slopes of lines, but we're going to, instead of looking at a line, we're going to look at a table. We're going to look at a table of points, and let me just pull up that worksheet. So here, what we're going to do, okay. Alright, so here what we're going to do is we have a table. So now, and this table is the same as just having coordinates. The coordinates are of xy's would be like 1, 5, 2, 10, and when you plot these coordinates, they actually make a line. But by looking at the table, what we're going to do is we're going to find the slope using the rate of change. And just like what we learned earlier, we know that your slope, which is also referred to as rate of change, is the difference in the y's divided by the difference in the x. Now when you're looking at a graph, you could say the rise over the run. Okay? So the difference in the y's. Okay, so this is what we're going to do. From our first y to our second y, we added 5. And if you see the pattern, our change is 5. From 10 to 15, added 5. From 15 to 20, we added 5. So the change in the y is 5. All over the change in the x. So what's the change in the x? From 1 to 2, it's just plus 1. From 2 to 3, plus 1. From 3 to 4 is plus 1. So it's 5 over 1. The change in the y divided by the change in the x. 5 over 1 is the same as just 1. I'm sorry. Excuse me. 5 over 1 is the same as just 5. So to write your function, you say, okay, now let's use functional notation, which is f of x is equal to, you go ahead and put your rate of change first. So 5 over 1, we simplify that to just 5, okay, x. And then if you need to add a number here, we could do that. But if we look at our pattern, if we look at our table, we don't have to. If you plug in the first x into this function, then we get 5. We get our first y. So we're done. Our function is f of x is equal to 5x. Okay, let me repeat that. If we plug in 1 here, 5 times 1 equals 5. If we plug in 2 here, 5 times 2 equals 10. If we plug in 3, we get 15, and so on. So there's no number we have to add to this to finish this function. We are finished. So f of x is equal to 5x. Let's do another example. Remember, it's the change in the y divided by the change in the x. So from -1 to 1, we added 2. From 1 to 3, we added 2. From 3 to 5, we added 2. So the change in the y is 2. Now what about the change in the x? From 1 to 2 is plus 1. From 2 to 3, plus 1. So on. Okay? So the change in the x, which goes on the bottom, is 1. And we simplify this as just 2 over 1 is just 2. So our function would be f of x is equal to the rate of change goes here, and then multiply times your x. Now go ahead and plug in a number. Let's go ahead and plug in 1. So if we plug in 1, 2 times 1 is 2. That's not -1. In this example, we have to do something else. So if 2 times 1 equals 2, how do you go from 2 to -1? Well, you subtract 3. Now let's do this again. 2 times 1, plug in your first number. 2 times 1 is 2. Minus 3, -1. Let's see if this function works with our next 2 points. Plug in your 2. 2 times 2 is 4. 4 minus 3 is 1. Okay, that works. Let's try one more. 3. 2 times 3 is 6. 6 times 3 is 3. Looks like we found our function. So our function is f of x is equal to 2x minus 3. So it looks like we found a pattern, a way to find an equation by looking at a table of numbers. So our first step is to find our rate of change, which is also known as slope. So our rate of change is the change in the y's divided by the change in the x. Let's do that first. -2 to 0, we added 2. 0 to 2, we added 2. 2 to 4, we added 2. The change in the y is 2 over change in the x. From 0 to 6, we added 6. From 6 to 12, we added 6. From 12 to 18, we added 6. So 2 over 6. Now we simplify this. Divide the top and the bottom by 2, and we get, well, if we divide the top by 2, we get 1. The bottom by 2, we get 3. So now we simplified our rate of change, or slope, to 1/3. So f of x is equal to 1/3 x. Now we're not done yet. Let's go ahead and plug in our x coordinate to see if we get -2. So when we plug in our x coordinate, 1/3 times 0, that's 0. How do you get to -2? Well, we subtract 2. Let's see if that works with our next x-coordinate. Let's plug in 6. So 1/3 times 6 is 2. 2 minus 2 is 0. Okay, that works. Let's do one more. Okay, so 1/3 times 12, that's 4. 4 minus 2, 2. Looks like we found our function. Our function is f of x is equal to 1/3 x minus 2. Okay, so here what we're going to do is we're going to find our function, and then what we're going to do is we're going to use our function to complete the table. Looks like we have 2 missing numbers in our table on the y section, or we also say f of x. Okay, so let's go ahead and start. We know our first step is the change in the y divided by the change in the x. Our first step is to find the rate of change. Okay, so the change in the y, we go -8 to -18. Looks like that's a difference of -10. Okay, so